look at it. Okay? What's that called? What's that called? Sodium chloride? Table salt. Simple. Let's try a few more. Let's see if you can get them. What's this one called? Got that one up there, calcium, and a couple of chlorides. Okay. What's it called? So calcium loses 2 electrons. That's why I had 2 pluses there. That becomes calcium chloride, CaCl2. So if I put a calcium together with an oxide now, see, one is +2 and the other is -2. So what's that called? If you look at this, you see the key is you want to get every plus has to be covered with a minus. It has to add up to 0. It's really simple. Did you guess calcium oxide? It's easy, isn't it? So if I have an aluminum, it's got 3 pluses, see there? And I combine that with a chloride, it's minus. How many chlorides would I need, and what would be the formula? What's it called? It's aluminum chloride, and the formula is going to be AlCl3. You're going to need 3 of those minuses for each one of those pluses. AlCl3, aluminum chloride. Simple, isn't it? Now if I take a nitride, it's got 3 minuses because it's picked up 3 electrons, and I put that together with an aluminum, what's going to be the formula for that? And what's it called? Look, we've got aluminum, we've got nitride, it's called aluminum nitride, and there's 1 minus for each plus. Every plus has to be covered with a minus because it has to add up to 0 for it to be a stable ionic compound. Tricky one? Here's a really hard one. Ready? Combine a calcium that's got 2 pluses together with a nitride with 3 minuses. Well, let me see. We stick that. Oh, wait a minute. We've got 1 left over. That doesn't work. So what do you think calcium nitride will be? Figure it out? It's not that hard. There's a trick though. If you wait, I'll tell you the trick. So if you look here, here's calcium nitride. And what's the formula? Well, we've got 3 calciums, those are the blue ones, and we've got 2 of the nitrides. And the trick, the way to figure this out is what's sometimes called the crisscross method. You take the number that's next to the blue calciums, which is 2, that means you need 2 nitrides, and you take the number next to the nitride, which is a 3, which means you need 3 calciums, because 3 times 2 is 6, and there's a total of 6 pluses. So we have 2 here, and 2 more there, and 2 more there, and we have, in terms of the negatives, to get this apart here, oops, stick together all the time, we got 3 and 3, we got 6 minuses, we have 6 pluses. So the crisscross method, you take the number that's next to the calcium, and that goes down underneath the nitride. And you take the number that's next to the nitride, and that goes next to the calcium. And you get Ca3N2. All right? Not hard. Now, an even trickier one, which is amazing, kind of fun, is going to be lead 4 nitride. What's 3 times 4? You think, using the crisscross method, and you have to get all the charges canceled out, what do you think the formula for lead 4 nitride will be? Let's have a look at it. It's really weird looking. This one's too big for me to hold in my hands. Look, we've got 1, 2, 3 leads. Can you see that? That's nitrogen. It's got 3 minuses. So you'd figure that 3 goes down below, and now the lead is 4, so we'd have to have 4 nitrogens. 1, 2, 3, 4. So it's going to be Pb3, 1, 2, 3, N4, 1, 2, 3, 4. Pb3N4 is lead 4 nitride. Pardon me. So using the ionic bond disc model, it makes it easy to see. The trick is you want to get to 0. The number of plus charges on the cations have to equal the number of minus charges on the anions. That's it. For every plus, got to have a minus. Simple, right? You got this. The Ionic Bond Disc Model is available from scienceglen.com. Have a look at it. Show it to your teacher. They're going to love this.